Hi.
Hi, everyone.
So we're going to talk about teaching JavaScript to students and how we kept our server alive doing that. So next, do I click over there? Oh. Hey, I did it. OK, so why would we want to teach JavaScript to kids? So a new project called the National Curriculum just rolled out in every state in Australia except for the New South Wales, and it includes the Digital Technologies curriculum. That curriculum has students learning to code from grade 3 through to grade 8, and in years 7 and 8, they should be using a general-purpose programming language to create interactive user interfaces. Does that sound familiar? That's JavaScript. So we decided to teach JavaScript to kids. And to do that, we wanted to create relevant projects that would motivate the students. So these should be things that make sense to someone in year 7, and then it's exciting for someone in year 7. We also wanted to introduce small bits at a time. And this is a bit tough. A lot of projects on the internet that try and teach JavaScript, they have big chunks of code, and we really want to do just a little bit, but it still needs to be relevant. And we also wanted to give really good feedback. So one of the most important parts of learning is getting feedback on your learning. And if that feedback loop is really tight, then you'll learn really effectively. If that feedback loop is loose, if you get your marks back for your essay a month later, you don't learn anything. Jess is going to talk about how we mark our JavaScript.
OK, so normally with our system, we mark student code in a linear fashion. We want it to be just like a unit test. So we're testing the results inside the student's program rather than looking at how they arrived at those results. So for example, if they have a loop that they're required to write, we don't necessarily make them do a while loop, but they could use a for loop. We're actually checking to see that they've got the outcome that we wanted. So in order to do that, we have to actually run their code. We do this inside a sandbox for a bunch of reasons. It gives us a lot of control. But one of the things we have to watch out for is keeping an eye on the resources inside the marker. If the student, and let's face it, they do often write really bad, inefficient code. If they have an infinite loop or they're going to make the CPU go mad, we want to make sure that they have those resources limited. We also make sure that they have isolated data and that they can't access things on the network that they're not supposed to get into. This means that we can make sure that their submissions aren't picking into other student submissions that are running at the same time. But perhaps the best benefit that we have for doing this approach is that it makes our page behavior really predictable. The student doesn't have to have a specific browser in order to use the platform and mark their code. We can control the features from JavaScript that we want to teach so that their browser doesn't have to support those same features. And we can predict what it will look like when they're actually marking. So if we take a screenshot of their page, it'll be the same every time that they run the code and across all of their different platforms that they're using. OK. Right, so inside the sandbox, we have a bunch of pieces fitting together. We have the heavy lifter in this situation is Chromium, we're running this in headless mode and accessing it via the dev tools. This enables us to set the page up and then peek inside the page context. This is done using a nice high-level API called Puppeteer. It bundles together actions that we want to perform inside the page. So for example, if we want to click on an element inside the page, we don't have to mess about by finding where on the page it is, moving the mouse across, clicking down and clicking up and so on. It's just bundled into one nice, easy-to-use click action. And it also makes it really easy to communicate over the top of the DevTools protocol, which is a very complicated but powerful protocol. The next thing we have inside there is a proxy server that basically handles our whitelisting, so that inside the student page, if they request out for an external resource like YouTube, then they get cut off. So no chance streaming YouTube inside our marker kits, also no mining Bitcoin. We have a web server that serves the submission up. This basically makes the student's workspace available inside the web server in the local namespace so they can access their HTML files, their JavaScript files, and any resources like images that we feel are important to the problem, and they can access locally without large URLs, which are very complicated for a kid that's age 12 to get a handle on. And then finally, we have the pièce de résistance, which is our marker, which is a smart level above the API that we're using with Puppeteer. This is designed for our problem authors so that they can write really good problems and mark the student's solution and give really good feedback at a higher level over the API there. Okay, so Ben's going to talk to you about the problem author's perspective.
So a common problem that we serve up within about an hour of the first time programming is a problem called Hallow name. And in this problem, you should take some input, like a name, and then say hello to that person. So if I said Ben, then the program says, hello, Ben. So how do we do that in JavaScript and HTML? So we've taken an approach that is maybe not as common as some other programs do or some other projects do. We wanted to keep it kind of honest and focus on doing HTML, but we have a problem, which is how do you get input without an event? So without having to declare a function. And so we decided to use prompt, which not a lot of people may have seen, but it's kind of old school, and it prompts up a dialog box, and you can enter some text. And it's not great, but it's really neat for students who are just beginning because it's blocking, so we don't have to do any events. And then the other thing we do is, it's a really old spec, but the ID of every object on your page is available on the window object, and so we can directly access the DOM elements like person just by writing person. And this allows us to write a really simple line of code that actually does a lot of different things without teaching a lot of concepts, which is important. So there are a few different things that you could do when you're writing a solution to this. A student could use variables, but then they want to alert their variable name, and then they set the text content. So this would hopefully fail. So we would want to say, oh, you weren't meant to alert that name, even though you have for debugging. And another solution might be they have used best practices and they've gotten the element by ID rather than using our window hack, and they've used variables. And we want this case to also pass. So we shouldn't be checking that they've done things the way we wanted them to do. They just have to get it correct. So how would we go about doing that?
Okay, so with marking modals, they're a little different to like a linear unit test, because when the modal happens, it's going to interrupt. So normally we would take an action like, say, click on a button and then expect the result. Maybe the button changes color to red. But when a callback is involved, the modal happens inside a different context to the area that we're trying to test, so we lose control of the page handles in the page at that point. We need to expect the modal will pop up before it actually happens. So Puppeteer actually makes it pretty easy to handle modals. It's got a nice API around this, but our marker API takes it a bit further and allows the problem author to expect that the next thing that's going to happen in terms of a modal is that it's going to be, say, a prompt. And it's going to have a certain prompt text, and it can be responded to in a certain way so that the student's code can then take that and move on with their solution. The other thing that, oh yes, right. This is an example from our marker that is showing the student that they have accidentally popped up an alert dialog instead of popping up a prompt dialog. This feedback is helpful because we're actually giving them some context about what happened when the error occurred. If we didn't have this hint about we click the button element first, then it's hard to keep track for the student of which part of the code the error is occurring in. The web technologies have got lots of different pieces fitting together, and that's a lot for the student to handle at once. So this helps give them some context. The other thing that we have going on with modals is that students use modals to debug their code. As Ben showed before, if you need to know what's inside your variable at any point in time, you probably are going to pop up an alert or a prompt because it's difficult for the student to work out how to get to the console and all of that sort of stuff. A prompt or an alert makes it obvious and apparent what's going on. They also will use it to find out whether they've got an event handler actually firing. So here's an example. They've left an alert in there saying, I'm inside this event, hooray. But what happens if they mark this code We're not expecting in the test for an alert to happen at this point, but we need to recover, otherwise our test will block forever trying to respond to this modal that has taken over the execution. So we give them, again, some feedback in order to allow them to proceed.
So this is another problem which I really like, which is a meme maker. So we want to have, this is where students are a bit further through and they are learning about events. And we want them to put text into an input field and then update the caption of a meme. So we have a input field, and that's the text that they've typed in, and a caption on an image. And when they type into the input field, it should automatically update the caption. So to do this, I've got this sample solution, which is how we would teach it, not necessarily exactly like this, but similar. And some of the things we've done here, again, we're using that same window ID trick. And the other thing is we're using the older style event handling, just setting the function onto the onInput. And that's just because it's a lot harder to write add event listener on an element than it is to set onInput. And it makes it's a little more confusing as well, because onInput is just one thing. Add event listener could be lots of things. And we really want to keep these things as simple as possible and stick to these kind of easier to understand concepts. So how would we go about marking that?
Okay, so this one is a bit more traditional. We're taking an action and expecting a result. But what if they, for example, forget to hook up their event handler? And this is the sort of thing that would be really easy for a young student to do. They implement their function, but when they click the button, nothing seems to happen. So we try and give them a bit more feedback in this situation. So there's a bunch of things going on here. First of all, we tell them what the error is, and in here we're expecting a certain caption, and then we tell them what it was meant to be. And we also give them the same context as before, the fact that we perform this action, and they can match up the thoughtful dyno here with the action that we actually took. And then we give them a clue. Did you hook up your event listener? This feature is really useful for our problem authors to set a specific hint with a particular test so that they can give the student context-specific clues as to what's going on. So if they forget to, if the result is not what we expect, it could be for a bunch of different reasons, but the test author has a fair idea of what they might have done wrong. That is what they can use that for. The other thing that's going on, what happens if their event handler never terminates? Obviously, if they've got an event, if they've got an infinite loop inside their code, it's just going to lock up our marker if we're not careful. So we don't want to hang that. And this feedback gives an example. We basically time out and then give them a hint that's tailored to the fact that their code timed out. Finally, just wanted to say, what happens if they're getting sneaky and start to do funky things with HTML injection attacks? It's just a note that because we're marking web technologies and then giving the feedback with those same technologies, it's really extremely easy to accidentally inject HTML into your own feedback messages. And so we've got a whole framework there that protects that so the student can't pop up an alert on their own window and think that they've hacked our system or something like that.
So the final project they do is a bit of a quiz, and we're just going to rush through this bit. This is like a BuzzFeed style quiz, and one of the big problems with this is that it's a form, and so they need to handle the event on the form. And of course, if you don't handle the event and prevent the default, then the page will navigate. They're going to need onSubmit, they're going to need prevent default, they're going to have their branching and looping and all of that stuff, and a lot more hidden details and concepts that they will have learned over the course of the project. So
for marking the final project, the main thing that was a real issue here was that page navigation is a factor. If they do it correctly, then there will be no page navigation, but if they don't do it correctly, and let's face it, almost all the time, the first thing they're going to do is hit mark before they've set up their event handlers or anything, it's going to cause a page navigation. So I could talk for ages on this one aspect. It was surprisingly tricky, given the way that the handles are set up inside the Chromium DevTools. So come and ask me about it if you're interested in that, because I think we're a little bit short of time here.
So there's lots of things we didn't have time to cover. We've done some stuff with request animation frame, some other event handlers. There's so much JavaScript that you can teach and that exists, especially with the DOM APIs. The course that we're developing is we're still working on it, and it should be coming out soon. If you have any questions about teaching JavaScript, about Puppeteer, please come talk to us. That's us. Also, the last bit.
Thank you.